it's a Starbucks per area. So based on the area of the country, what has the highest density of Starbucks? So to do that, we need to know how big each country is. For example, here we've got Saudi Arabia. What's the area? And it looks like in our country, we've got shape area and we've got shape area here. And they look like they have just about the same numbers. They're at least close, but we don't know what the units are and we don't know how updated these values are. I always recommend recalculating area for yourself. If you can't, it's grayed out. It's because that field is right protected. Sometimes I'll check for another one. Oh, this one's available and we don't really care what used to be there. So I'm going to calculate geometry. My shape error, and I want to calculate the geodesic area because that's the area based on the curved surface. Let's do it in square kilometers, and I don't need a coordinate system because it's going to be geodesic and it can use the datum that we're displaying in. We may find that it doesn't change that much, or it might change a lot. I don't know. But right now we know that this is in square kilometers. Doesn't really matter. But now we need to know what the count per area is. And to do that, we're going to do a field calculation. And we need to have a new field to do that in. So I'm going to add a field. We're going to call it density. I want it to always be float because I want to have decimals. I don't want arc rounding or truncating on me. So floating point. And I'm going to close that. And yes, I want to save it. All right. And then I right click on this new field and we're going to do a field calculation. So calculating geometry, remember, allows you to calculate lengths and areas and perimeters and XY coordinates. It's the geometry. But field calculation allows you to calculate between fields or columns. And that's what we want to do. We want to divide. We want our density to equal our shape. Nope, not that. Starbucks per area. So we want, oh, not that. Sorry. Count of points is the number of Starbucks divided by our shape area that we recalculated. And we know that's correct. All right. And then if we sort this descending, that's where we got Singapore. So Singapore has the highest density per size of the country, followed by Bahrain, South Korea, Kuwait, Japan, the UK. Interesting, right? So if you had not chosen decimal, these would all be zeros and you wouldn't get any kind of ranking. So if you had used, when you added your field, if you had made the field long, that's an integer. Short, double, those are all integer fields. So something to be quite aware of. All right, we're making progress. Question 3. What is the area in square kilometers of ACVAL 6% from the seismic hazards layer? So basically, this is asking us to isolate the seismic hazard polygons that have an ACVAL of 6% G, and then we're just going to calculate that area. All right, this is a piece of cake. Turn off this stuff. Okay, and we're going to go back to our seismic hazard. Let's zoom to it so we can see what we're working with. Close this stuff. No, and close that. Okay. All right, we're going to do a select by attribute on this thing. I like to do it from in here, where our ACVAL is 6. And it looks like we've got 6 is here, and this does not look right at all. All right, so I have an answer here of around 32,000 square kilometers. This is a little bit alarming that my data set and my selection are matching, and they shouldn't. So let's see here. Our selection is 16 out of 1600. Let's see. And our sum here is the same. It says we've got a count of 16. All right, I think I know what happened. I figured that the area in square kilometer had already been calculated for all the polygons, but it hasn't. They're all 0 except for the ones that we had selected. That's why the sum of the selection matched the sum of the data set. So repeating that, if we select by attribute, the input rows are seismic hazard, ACVAL is equal to 6, and we get those 16 records back. And then I go back in here and visualize the statistics. You can see that our data set has a different mean for the data set and the selection, but here the sum is the same because we didn't calculate areas for any of the other polygons. So technically this is the correct number here, and this is incorrect. So it should be more like 500,000. How could we test that? I think it might be useful to do a couple things. Like we can right click and we could data export those features and turn them into their own data set. That would look like that. Then we're going to turn off our inputs so that we can just see our outputs. And so this makes sense to me that these are the different polygons. They're kind of like isoplepth areas, aren't they, of equal ACVAL values. It might be difficult to evaluate the area of one of these, but if we selected this one and looked at it in the attribute table, okay, so it looks like if we select this record, we've got an area in square kilometers of around 14,600 square kilometers. And if we set up our measure tool to measure area, geodesically using metric units, and then I'm just going to roughly kind of trace and click, not being super careful. I just want to get a ballpark. All right, a sum of square kilometers of 14,140. Definitely in the ballpark, considering I skipped some corners there. Okay, that's how I would verify it. It sounds like we're definitely within reason. And so if we look at this whole data set, clear our selection, and look at all of the features, and we go back and sum this guy, visualize our statistics on our good field, we've got a sum of 564,946 square kilometers as the total area for our ACVALs of 6% G. All right, it's a lot. There you go. Questions, let me know.